Okay guys, welcome back to factoring by grouping. So now instead of letting you know what's in the group, we have to discover it ourselves. My suggestion is always to put the first two terms in parentheses and the second two terms in parentheses and look at what they share. So what do 2a and a plus b share? They share an a. If we divide by a, that tells us what's left, 2 plus b. The second two terms share a 9. So we factor out a 9 from the second two terms, and they leave us also with a 2 plus b. That means this 2 plus b is shared, so we can factor it out in front. And these two terms that are on the outside become our other term, a plus 9. Simple as that. Okay, I'll leave number 12 for you guys to do, and 13. We'll go ahead and do 14 though. So in 14, again, let's group. The sign always goes to the third term, so make sure you take it with it. 20k squared and 10j squared, or 20k cubed and 10j squared k squared. Share a 10 and a k squared, leaving us with 2k minus j squared. The second set. Now, if the first term is a negative, you always take the negative with it. So minus 2j. Leaves you with 2k minus j squared. Now again, if you do this right, the inside should match if it can be factored by grouping. So this 2k minus j squared goes out front, and the 10k squared minus 2j is our other factor. So what is factor by grouping really? So, you know when we multiply normally a binomial together, when we distribute or FOIL, we have the two middle terms we combine. So it looks like we only have 3 terms at the end. Our goal when we factor things, when they don't have a common factor, is to break apart the middle term. So undo when we combine the terms, break the middle term apart into its two components, and then factor by grouping. This is an essential skill to factor by grouping. Now, when we're factoring trinomials generally, it's undoing FOIL. So let's look at x plus 5 times x plus 8 as an example. When you distribute, you get x squared plus 8x plus 5x plus 40, and then we combine the middle terms. Now, one easy way to look at this is these two numbers, 5 plus 8, add to 13, whereas 5 times 8 multiply to 40. So this is an essential skill that we need to look for to kind of determine what numbers we've got. So our general steps are going to first be factor out any GCF before you do anything. That always has to go first. If they have a common factor, factor it out. Look at the constant. Consider all the pairs of numbers that can multiply. So if all you saw was the 40, you're looking for numbers that multiply to 40, that add to 13. And then make sure the two numbers you pick add to the middle term, and then factor into your appropriate pairs. So we're going to only start when leading terms are 1, and we'll go from there. So let's just practice finding pairs. List the pairs of 36 that add to negative 13. Now, one thing to note, if two numbers multiply to a positive but add to a negative, they must both be negative. So we've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Now, if they're both negative, which ones add to 13? Negative 4 and negative 9. Let's try again with negative 72 and 21. If two numbers multiply to a negative, one of them has to be positive and one of them has to be negative. Got 1 and 72. The bigger one has to be whatever sign they add to. So we need the bigger one to be positive. So negative 1 and 72, negative 2 and 36, negative 3 and 24. You don't have to go all the way out. If you find the one you're looking for, you can stop there. So negative 3 and 24, the two that do that. Okay, so let's try completing the factoring. Here, they give us the answer, one of the factors, and we have to figure out the other one. So x squared minus 12x minus 28, they told us one of the things is x minus 14. What we know about 14 is when it multiplies by the other number, it gets negative 28. So negative 14 times some number equals negative 28. That number is 2. Does negative 14 plus 2 add to negative 12? Yes. So the missing factor is it's x minus 14 and then x plus 2. I'll leave 4 for you to practice. Let's just factor when they aren't giving us any help. Y squared minus 17y plus 66. So we're looking for factors of 66. So 1 and 66, 2 and 33, 3 and 22. It doesn't go in 4, 6 and 11. Okay. So we know it's 6 and 11, and they both need to be negative. So this factors into y minus 6 and y minus 11. And that's the goal here. Let's look at number 6. Two numbers that multiply to negative 84 to add to negative 5. One's positive and one's negative. The bigger one has to be negative because the middle sign is negative. So, okay, 1 and negative 84, 2 and negative 42, 3 and negative 28, 4 and negative 21. 5 doesn't go in. 6 and negative 14. 7 and negative 12. Okay, finally found one. 7 and negative 12. That means my factors are z plus 7 and z minus 12. There can be more than one variable here. If we think about it, all having multiple variables means is instead of having a constant on the second term here, I'm going to have a constant and a variable there. So we know from looking at it, we have a j in the first term. But we also know, because there's a k squared there, that there's also going to be a k in the second term. So when I'm looking at the factors of negative 18 that add to 7, I know that those numbers are actually going to be paired with a k. So we've got negative 1 and 18. Looks like negative 2 and 9. Looks like negative 2 and 9 works. So it's j minus 2k and j plus 9k. So just keep that in mind if there's a second variable there. That's how this works. It'll go in with the numbers in the second set. Now lastly, let's look at some where we have to factor out a greatest common factor as well. Factor the trinomial completely. Okay, so for now, if we see a number in front of the x squared, we don't know how to deal with that yet. We'll learn it in the next section. So you can expect that everything should be able to divide by 6. And by that I mean it factors out in front. Then it's x squared plus 12x. 162 divided by 6 is 27. So the 6 is still a part of the problem. Now we're looking for two numbers that multiply to 27 that add to 12. Looks like those are probably 3 and 9. So it's 6 times x plus 3 times x plus 9. So don't get rid of the greatest common factor. We'll talk about when there are equations, you can divide by them, but for now, don't. Similarly, you can have a greatest common factor that's not just a number, it could also be a variable. So not only is the negative 8 a common factor, this x squared, there's at least two x's in all these terms, you can factor that out as well. So negative 8x squared out front leaves x squared minus 8x. 520 divided by 8 is 45. No, I mean, not 45, 65. What am I saying? 65. Okay, so now we're trying to factor this. The x squared minus 8x minus 65. Factors of negative 65 that add to negative 8. So, of course, one is negative, one is positive. So ends up being negative 13 and 5. So we have negative 8x squared. And then we've got x minus 13 and x plus 5. And that is all for 5.1 and 5.2.